down at your feet. Now, think about the top of your head. It feels entirely normal to assume that your entire body is the exact same age. But it isn't. Right now, according to Einstein's theory of relativity, your head is physically older than your feet. By a few billionths of a second, the top of your head has experienced more time than the bottom of your feet. How is it physically possible that different parts of your own body are aging at different speeds? To solve this mystery, we have to look at the invisible culprit dictating reality. We all feel like time is a universal metronome. Isaac Newton believed this. A second on Earth feels exactly the same as a second anywhere else in the universe. But the universe has one unbreakable rule that ruins this perfect clock. The speed of light is an absolute constant. It can never change. No matter how fast you are moving, light always travels at exactly the same speed relative to you. But if the speed of light can never change when you move fast, what does change? Watch what happens when we push this idea to the limit. To see this in action, we need to build the simplest clock in the universe. A beam of light trapped between two mirrors. Tick, tock. Now put that exact same light clock on a moving bullet train. Look at the path the light has to take now. Because the train is moving forward, the light doesn't just travel straight up and down. It travels diagonally in a zigzag pattern to keep hitting the mirrors. A diagonal line is physically longer than a straight vertical line. The light has to travel a greater distance. And that creates a problem, a huge problem. Remember the unbreakable rule. The speed of light cannot change. So if the light is traveling farther at exactly the same speed, how does it still reach the mirror? It takes more time. For the person watching the moving train, time itself physically stretches out and slows down. To the person on the train, everything feels perfectly normal. Motion stretches time. This isn't just a thought experiment. It is a biological reality for a man named Sergei Krikalev. He spent 803 days orbiting Earth at extreme speeds. Because he was moving so fast relative to us on the ground, time slowed down for him. When he returned, his biological clock, his cells, and his watch were all about 0.02 seconds younger than if he had stayed on Earth. He is, in a very real sense, a time traveler into the future relative to the rest of us. We've solved half the mystery. Motion bends time. But what about the other half? What if I told you that you don't even need to move to warp time? Gravity doesn't just pull things down. Mass actually bends the fabric of space-time itself. Imagine placing a heavy bowling ball onto a stretched sheet. The sheet bends downward. Space-time behaves in a similar way around massive objects like Earth. The deeper you go into one of those gravitational valleys, the slower time passes. Gravity stretches time just like speed does, and the answer lies in the ground beneath you.
The universe is full of unsolved mysteries, and we
Think about how you are standing right now. Your feet are physically closer to Earth's center than your head. That means Earth's gravity is pulling just a tiny fraction harder on your feet. Your feet are slightly deeper in Earth's gravitational well. Because they are deeper in that well, time ticks ever so slightly slower for them than it does for your head. Every physical process, including the chemistry that underlies aging, is happening slightly slower at the bottom of your body. You are literally stretched across two different rates of time, You might think a few billionths of a second doesn't matter. But what happens if we ignore it? Look at the GPS satellites orbiting Earth and connecting to your smartphone. They are moving incredibly fast, which slows their clocks down by about 7 microseconds each day. But they are also much farther from Earth's gravity, which speeds their clocks up by about 45 microseconds each day. If we didn't actively correct for this strange tug-of-war between speed and gravity, the clocks on those satellites would drift. Within a single day, GPS positioning would begin losing accuracy. Modern global navigation works because we mathematically accept that time is flexible. So, what happens if you keep pushing this idea further? According to relativity, as an object approaches the speed of light, time slows dramatically relative to outside observers. And at the speed of light, our usual description of time no longer applies. There is no universal metronome keeping perfect time across the universe. Your experience of now depends on where you are and how you move. And at this very moment, the universe is subtly bending itself to accommodate the distance between your head and the feet you are standing on. The top of your head is already living slightly further into the future than your feet.